Well, hello there. It's Mr. Pouts with Section 12.5. Section 12.5 is all about circles in the coordinate plane. We've been dealing with circles all chapter, and we're going to look at them in the coordinate plane. So if you've ever thought of it before, we've had formulas to write equations for lines. You know, like y equals mx plus b. We've had formulas of equations of parabolas, like uh, x squared plus, well, ax squared plus bx plus c, and there's all these other formulas to write things like even a v you can use an absolute value formula. So why not have a formula to make a circle? And that's what we're going to do today. So our objectives for section 12.5 are to write the equation of a circle and also to find the center and radius of a circle. And these are all in a coordinate plane. So it's pretty neat. There is actually a formula that you can use to draw a circle, to graph a circle. So when you get into using graphing calculators and whatnot, you can make circles and have all kinds of fun with that. And you can find intersecting points of circles. And so here's what we're going to do. We're going to start off with theorem 1216. Can't believe we've had that many theorems already. But the standard equation of a circle. So look over to the right. There's your circle. We have our center, which we're going to use as HK. Those are the letters we're representing with the x and y of the center of our circle. R is our radius, and xy would be any point on the circle. So the standard form equation, and it's derived from the distance formula, looks like this. X minus h squared plus y minus k, well, I'm losing it, there you go, squared equals r squared. So, again, h, k make up the center. And then r would be the radius. And remember, this part is important. It's squared. So you could have 16 over there. You have to know that the radius is actually 4. Right? It's not always going to have the squared symbol. So we could prove this theorem, this formula from the distance formula. It's actually only takes like 2 or 3 steps. We're not going to do it right now for the sake of time, though. What we are going to do is work a little bit with that formula. So first part, we're going to write the standard equation for a circle. So we're given enough information, we're just going to write it. Okay? Remember that formula. Rewrite it. X minus h. H is the x value of a center of a circle squared. Plus y minus k squared equals the radius squared. So if we're going to plug in the center as 0, negative 8, what I'm going to do here is plug in x minus 0 squared plus y minus negative 8 squared equals 4 squared. And to simplify that a little bit, that would just be x squared. Again, yes, you might see it like this. Plus y plus 8 squared equals 16. That's as simplified as we're going to go, because that tells us all we need for that circle. You can actually take it and graph it, because you'll have the center point, and you'll also have the radius, and you can go from there. Number 2, I'd like you to try this one on your own. Write the equation of that one. So plugging in, we have x minus negative 3, and that's squared again, plus y minus 2 squared equals the square root of 10 squared. Now the square root of 10 squared, that's just 10. This x minus negative 3 would be changed to x plus 3, of course, squared plus y minus 2 squared. There you go. There's the equation of that circle. Excellent. All right, let's take this now, and we're going to have a center. We're going to get given the center and the point it goes to. We have to figure out the radius. So to do that, to write the equation, we have to find the radius first. So we have our h and our k. Now we have our x and our y. We don't have the r though. So let's plug it all in. 6 minus 9 squared plus 4 minus 12 squared would equal r squared. 6 minus 9 is negative 3, and negative 3 squared is 9. Plus 4 minus 12 is negative 8. Negative 8 times negative 8 is 64. And that means that would equal r squared. So 64 plus 9 would be 73. So r is equal to the square root of 73. That's the radius. So you can then take the radius and our center and write the formula. So going back here, did I plug in the wrong spots? It should be 9 minus 6 and 12 minus 4, but that won't change it at all. Awesome. I just noticed that. But anyway, so x minus, what's our center? 6. That's squared. Plus y minus 4 squared would equal to square root of 73 squared, which is just 73. There's our equation of that circle. Didn't take us too long, even without the radius. All right, moving on. Find the center and the radius of the circle, then graph. Okay, we're going to actually look at the formula this time. So the center, that's a 1. That's a plus, so this would be minus a negative, so we have negative 5 would be our center. So 1, negative 5. 1 over negative 5 right there. And the radius says 4 there, so that would be 2 squared. So the radius is 2. So if I graph that, I'm going to use that center, and I'm going to find the radius. I'm going to go 2, so the radius goes all the way to there, all the way to there, all the way to there, all the way to there. Those are the only spots that we can actually make the radius. And we're going to kind of estimate. Now, typically, I'd say take a compass and make a perfect circle. But we're going to kind of estimate this circle and try to make it as perfect as we can. All right, and there's our circle. Got the center, got the radius, boom. All right, last one on this page. I might have 1 or 2 more examples, but this one says write the standard form given the circle. So we're going to have to find the center first and the radius. Oh, going crazy again. Center. All right. The center we have is 3, negative 4. Looks like the radius for this one is also 2. All right, so the standard form of the equation, we have x minus 3 squared plus y minus negative 4, which would be plus 4, squared equals 2 squared, which is 4. And there we go. Not so bad, huh? All right, so there's I think two more examples. Let's just look at them, see. So it says, write the equation of a circle with a diameter ST. And we're given the points of ST. How would we figure out the radius? Well, or the center. How would we figure out the center, too? If that's the diameter, well, it goes from here to here. We're going to have to use the distance formula and take half of that. So remember, distance formula, we'll do 10 minus 2 squared plus the x's. Well, I guess it doesn't matter which one. I did the y's first, but x's would be 6 minus 0 squared. So that's 8 squared is 64. That's 6 squared is 36. That's 100. The diameter equals 10. So that means that the radius then is equal to 5. Okay. How do we find the center then? Well, you might remember the center would be right in the middle of these 2 points. So we're going to find the midpoint of them. And the midpoint, you just take the average of the x's and the y's. So this is a great review for finding midpoint of 2 points. So 0 plus 6 all divided by 2, and then 2 plus 10 all divided by 2. So the midpoint, which is the center, would be 6 over 2, which is 3, and 12 over 2, which is 6. So that is the center. Not too shabby there either. Now we can put the equation together. X minus 3 squared plus y minus 6 squared equals 5 squared, which would be 25. And one last problem for you. Let's look at this one. Sketch the graph of each equation and find all points of intersection of each pair. So this first one, let's figure out what the center is. The x is, so it's plus 2, which would be minus a negative. So we have negative 2. The y, there's nothing there, so it's 0. And the radius is 3. So I'm going to graph that and see how that helps. We'll do that first. So negative 2, 0. Radius of 3, that goes all the way out. I'm going to kind of make that work here. Now this one says, so this would have a slope of negative 1. Linear 1. Good review. Negative 1 over 1. And the b value, the starting point is 1. I'm going to make this blue, actually. So 1. And then we go negative 1, down 1 over 1. Down 1 over 1. It actually looks like it's going to intersect at 2 of the points here. I didn't draw this circle perfect, but look at this line. That's one point of intersection, that's another point of intersection. So our points of intersection look like negative 2, 3, and 1, 0. And there we go. So that's where you're given two functions and finding really that's a system of equations, just we have a circular equation, which is all right. All right, there's an error analysis, I believe, for you to work on. Try to figure that one out and answer the 2 closing questions. What is the equation of a circle, and how can you identify the center and radius of a circle? And make sure you reflect on the 2 goals, which we talked about at the beginning, to write an equation of a circle and to find the center and the radius of a circle. Have a good one.